Okay, let us find this problem. So this says a movement of elbow. So inside the wall of a house, an L-shaped section of a hot water pipe consists of a straight horizontal piece of 28 cm long and elbow and a straight vertical pipe of 134 cm long. So you see, what is this problem? So this is figure number 19.14. So this is, let me write. So this is figure 19.14. So what you have, so this is the house. So this part, this the rectangular block is your house. It's not your house, maybe somebody else's house. So this is again house. So this is house. And this house has a pipe that can flow the water inside the house. This is the first floor, this is the ground floor. So there is a pipe. And this pipe has a horizontal section and this pipe has a vertical section, and these two sections are joined by a elbow. You have seen elbow, this kind of thing at your home. So this section has a length of 28 centimeters. See, the horizontal section is 28 centimeters. So this is 28 centimeters. Now you see the vertical section, question says this is 134 centimeters long. So vertical section is, you have 134 centimeters. So this is the vertical section you have. Now a stud and secondary story floor hold situation, the ends of this section copper pipe. So this is a copper pipe. Now this is given to you. So the pipe is made up of copper. So it's a copper pipe. Now the question says find the magnitude and direction of displacement of the pipe elbow. So this is the pipe elbow. So you have to find what is the displacement of this pipe elbow when the water flows in turn on, raising the temperature of the pipe from 18 degrees centigrade to 46.5 degrees centigrade. So you see, initially there is a cold water that is going through this pipe, or maybe no water. At that point of time, this pipe has a temperature of 18 degrees centigrade. So initial temperature is given to you. So that is T1. Let us call this as a 18 degrees centigrade. That is given to you. Now pipe starts water flowing inside this pipe, and the water is hot. Now the water temperature is T2. So T2 is, let us say, 46.5 degrees centigrade. So what will happen? So as the water goes here, so there is a temperature change. So length will increase. So this length will increase, and this length will increase in this direction. This length will also increase. This will increase in this direction because this point is fixed point. It cannot increase in this direction. This is a belted point from the building. So this is a fixed point. This point is again a fixed point, you see here. So this point is fixed point, so this cannot go this side, so I have only one option. This elbow can move only in this direction. So now you see very clearly. So if I see the elbow point is 0.00 point, so this is my 00 point, so this is elbow. If I write only elbow, I am only interested in elbow. So initially my elbow is something like this. So this is my origin. Now if you change the temperature, so what will happen? So this is my initial elbow. This will go in this direction and this will move in this direction. Are you getting or not? So finally you see. So this is the movement of elbow in this direction and this direction. So you see, if you add these two deflections, so this deflection and this deflection. So if you add these two deflection, what you will have? You will have, so this point moves in this direction as well as this direction. So this vector plus this vector. So finally it will reach up to here. So this point is reaching up to here. So final location will be something like, so the initial pipe is this. So this is the initial pipe. Now finally this point has moved up to this point. Are you getting or not? And now the pipe will be slightly, because this point is fixed, the top point is fixed. So this is the top point. This is fixed. The horizontal point that is also fixed. So pipe shape will be something like, so pipe will look something like this. Of course this pipe will be looking something like this. Our problem is this deflection is so small, so this will this look like mainly horizontal. So this line, this deflection is very small. So pipe, this horizontal and vertical part, almost horizontal and vertical. This angle will be very small angle. So deflection will be very slow, very low. We can find this value. So deflection will be very low, very small. Are you getting or not? So deflection will be very small. So this is the we can gauge. So let us call this deflection is dx and this deflection is dy. So in this direction you have a deflection of delta x, and in this direction you have a delta y deflection, and that is easy to find. because if I know the formula L is equals to L naught change in length, that is delta x is equals to, if you remember the formula, we have said one formula, delta L is equals to L naught 1 plus alpha delta theta. Are you getting or not? So this is the change in temperature, theta 2 minus theta 1. Now one more important point for this problem, alpha of copper should be given to you, that is given. So let us say alpha for copper, that is given to you, and this value comes out to be 17 into 10 to the power minus 6. So this is 17 into 10 to the power minus 6 centimeter per degree centigrade. So if you change the temperature by 1 degree centigrade, there will be 17 into 10 to the power minus 6 centimeter increase. So let us say if you plug this value, L naught is, you see L naught is initially 28 centimeters, so delta x is 28, let me check, yeah, 28, so this value is 28, so you have a 28 centimeter length. So let me write here, so this is centimeter minus per second, so this is delta L is 28 into 1 plus, and alpha is 17 into 10 to the power minus 6, and delta theta is 46.5 minus, so this multiplied by, so 46.5 minus 18 degrees centigrade. Are you getting or not? Now you have to solve this value. If you solve this one, do this calculation. If you multiply, this comes out to be 1.36 into 10 to the power minus. Okay, let us calculate delta y. We can calculate delta y also. So delta y is equals to, this length is 134. You can check your program. So L naught vertical height is 134 centimeter. 1 plus alpha theta, alpha is same, 17 into 10 to the power minus 6, and change in temperature is again same, 46.5 minus 18. And now if you solve for this, you will have, this comes out to be 6.49 into 10 to the power minus 2 centimeter. So 6.49 into 10 to the power minus 2 centimeter. Basically now you can calculate the resultant displacement delta r. So you see, delta r will be root over under root delta x whole square plus under root delta y whole square. So this value comes out to be 6.49 whole square. So this is 1.36 into 10 to the power minus 2 whole square plus we will have 6.49 into 10 to the power minus 2 raised to the power minus 2, and this is whole square under root. If you calculate this value, so this comes out to be 0.663 mm, 0.663 mm. So you see, we can calculate the theta also. So what is happening? So you see, I have a initial elbow position is here, and now this has displaced delta x in this direction, delta y in this direction. So finally this elbow has now reached up to this position. So what is this deflection? This is 0.663 mm. So this deflection is a small deflection, and that's why I said initially this deflection is a small deflection. Now we can calculate theta also. So what is the tan theta? So you see tan theta in this case will be delta y over delta x. So delta y you have calculated. So delta y is 0.663 mm. So 0.663 mm. And divided by delta x. So delta x is, you see, 1.36 into 10 to the power minus 2. So 1.36. No, this is delta y is not. So this is 6.49. You see, so this value is wrong. So I have to write again. So this value is wrong basically. So 6.49 into 10 to the power minus 2. So let us write 6.49 into 10 to the power minus 2. And what is delta x? So you see here delta x 1.36 into 10 to the power minus 2. So this value is 1.36 into 10 to the power minus 2. Now if you solve these two values, theta can be calculated, and theta, so this is tan theta comes out to be 0.649. So this is 0.649 divided by 0.136. And if you solve for theta, this comes out to be around 78.2 degrees. So theta is 78.2 degree. So this is 78.2 degree. Are you getting or not? So this is theta. Initial theta is something different, and now it has changed. So let me rub this one. Okay. So now you see what is happening. You have this elbow initially here. Now it has deflected by length of 0.663 mm at an angle of 78.2 2 degree. Obvious.